Hi smart people, and welcome to my channel. In this video tutorial I want to show you how to resolve this physics problem on ideal gas equation. If you're not familiar with ideal gas equation and how we do convert temperature from degrees Celsius to maybe Kelvin and all that, just please keep watching to the end. And if you're a new person visiting the channel, please hit the subscribe button. And if you're a returning subscriber, you're welcome. Please make sure to like this video. All right, so let's read through the question. A cylinder contains oxygen at a temperature of 20 degrees Celsius and a pressure of 15 atm, that is atmospheric or atmosphere, in a volume of 100 liters. A piston is lowered into the cylinder, decreasing the volume occupied by the gas to 80 liters and raising the temperature of 25 degrees Celsius. Assuming oxygen to behave like an ideal gas under the same condition, calculate the new pressure. So this looks a bit cumbersome and the question is just quite much, but it's not a problem. I always say that in my physics class, you will learn how to fetch out the parameters given in the question, and that will make the whole thing easier for you to be able to consume. So let's begin with bringing out the parameters given in the equation. But before then, you should remember that ideal gas equation. Let's have the solution here. Ideal gas have this equation, PV equal to N RT. Most of you are familiar with this already. If you're not, this is the ideal gas equation, where P is representing the pressure, this V is for velocity, not velocity, excuse me, that is for volume, all right? And then of course we've been mentioning volume and also the value. I think it's measured in liters here, all right? Some cases it will have another unit for which they want to quantify the volume of that, whatever it is they want to talk about. All right, and then we have N. We have the arrow, and I think these are parameters associated. Here is temperature, and I think this is the ideal gas constant, right? And the number of moles or thereabouts. So I think if you remember what they are, if I'm not correct, you can drop it in the comment section, because it's been a while I visited this. So let's expand this problem. Checking this problem, you notice that we're having different values of temperature, different value of volumes, different values of pressure. That will help us to expand this problem by developing, since we have two values, you can say P1, V1, two values of pressure and also volume and inclusive temperature. This is how we could just easily mesh them, because by the time you make this NR is subject of the formula, you have this to be PV all over T, which is equal to N arrow. So from here, you can be able to develop the first pressure, first volume, first temperature, and also the second pressure, second volume, and also the second temperature. And if you read through the equation, you will notice that what you are asked to calculate is the pressure. Calculate the new gas pressure. So you can easily make the pressure here the subject of formula, just depending on how you want to go about this problem. You can substitute your values and then eventually make the pressure. You can equally start from here to make the pressure the subject of formula. To do that, you have to multiply this over there. And if you, more like you're cross multiplying this to this and this to this. Okay, let's keep things simple. So if you do that, what you'll be having is P1, V1, and T2, which is equals, here we have P2, V2, and if this crosses to this part, you have T1. Since you're looking for pressure, you divide both sides by V2, T1. We're doing this in a simplified form so you don't have problems. If this cancels out with this, you therefore will have P2 to be equals P1 V1 T2 all over here we have V2 and T1. We've made the pressure, the second pressure, the subject of the relation. So now what we need to do is to start fetching out the parameters given in the problem. If you read through the question, you will notice that the first parameter you're having here is the temperature. A cylinder contains oxygen at a temperature of 20 degrees Celsius. What do we need to do? That means the first temperature given to us, T1, will be equal to 20 degrees Celsius. But you need to convert this to Kelvin. And for you to convert this to Kelvin, I think I need to teach you guys, or maybe explain some few things that will make you understand how these things work. The major difference is that when water freezes, you know, of course, when water freezes, a Celsius thermometer will read 0 degrees. A Celsius thermometer will read 0 degrees when water freezes, and a Kelvin thermometer will read 273, I think 0.15 thereabouts Kelvin. Now, for us to convert from degrees Celsius to Kelvin, you simply add 273. That's the first thing you need to do. You add 273 to whatever value of the degrees Celsius that is given in that problem. Say you have 20 degrees Celsius, or let's say 50 degrees Celsius. You just need to add that to 273, and then that will now be in Kelvin. That's exactly how you do this conversion. As if that was not enough, the next thing you need to understand too is that the standard temperature is defined as 0 degrees Celsius, which translates to 32 degrees Fahrenheit. And also, maybe you can have it, you want to have it in Kelvin, which is 273. We've said that before, 5 Kelvin. So this is the freezing point of the water, all right, at sea level in the air, or maybe in standard pressure. So the next thing we have in that problem that is given, if you read through the question again, you'll notice that we have pressure, which is 15 atmosphere. So you can have this point, pressure, which is P1, to be equal to 15 atm. We have also volume given. If you read through the question, you notice that the volume is 100 liters. So you have volume V1 to be equal to 100 liters. As if that was not enough, let's see another quantity that is given in the equation. You see, a piston is lowered into the cylinder, decreasing the volume occupied by the gas to 80. That's the second value of the volume, which is V2 equal to 80 liters. That's not all. If you further go through the remaining parameter in the equation, I can see that we have temperature to be 25 degrees. And because the temperature is 25, which is T2, 25 degrees. Remember, we need to add this one to 273. So we have this 25 degrees Celsius. When we convert it, it becomes 25 plus 273. And then the result will definitely, when you add this up, I think it should be giving us 298 Kelvin. Similarly, for that T1, which is 20 degrees Celsius, when you add it to 273, you have the result to be about 293 Kelvin. Now that you've gotten the whole parameter completely, we need to substitute the whole of this parameter into this equation we're having here, just for us to be able to evaluate P2. So finally, we have that P2 will be equal to, what is our P1? The value of P1 is 15, so we have 15 multiplies by what's V1, that's 100, times what is T2. T2 is given as 298. You have to divide the whole of this expression by the denominator, and you have V2 here to be 80, and that multiplies by T1, and the value of T1 is 293. So finally, by the time you evaluate this numerator and denominator, you definitely will have the final answer to be within 90 atm. So please make sure to use a calculator to evaluate this and drop the answer in the comment section. I hope you found this video helpful. Please make sure to like, subscribe to the channel, and share. I'll see you when I see you.